All right, I was asked to go over free response 63. This is a bit of a difficult problem, so I'm going to go through it. I've already actually gone through it, and I had some technology issues, and my original video got deleted. So instead of going through all the work again, I'm just going to kind of walk you through about how I got my answers here, and hopefully that'll help you when you have a similar problem like this. So in this problem, we're dealing with an apartment building elevator that has a capacity of 2,000 pounds. We're supposing that the men in the building have a mean weight of 185 pounds and a standard deviation of 15. The women have a mean weight of 135 and a standard deviation of 10. And both weight distributions are normal. It's good to know that. We want to find the mean and standard deviation first of the combined 7 men and 5 women, assuming all 5 weights are independent. So what I initially started with was, I know that if I'm combining random variables, I can add their means, and that will give me the mean of both of them combined. So the way I started out here was I knew I was dealing with 7 men. So I wrote them out individually. 185 plus 185 plus 185, did that 7 times. And I did 135, the women, did that 5 times. I just did this to illustrate how I used the formula, because ultimately, many of you who have probably done this problem did the same thing. You just end up doing 7 times 185 plus 5 times 135. I just like to illustrate using the formula why we got to where we did. So then I got myself a nice mean weight of 1,970 pounds. The standard deviation, this is a bit trickier. Now a lot of people would be inclined to just add them up, but you'll notice I have the standard deviation squared here. Why? Because you always have to find the variance first. If you're combining random variables, you use the variance and then find the square root of your variance. So what I did here was a very similar strategy. I could literally write out 15 squared 7 times. Why? Because that represents each man and the standard deviation of each man's weight. I could write that 7 times. I just went 7 times 15 squared. That's why it got there. So again, it's the same strategy. You're just adding them and squaring them. So again, I did the same thing with the women. I could have wrote individually 10 squared plus 10 squared plus 10 squared. But instead, I went with multiplying. A little bit easier. And then I figured them out individually, and I got a variance of 2,075 pounds. Now remember, the variance is the average squared distance from the mean. To find the standard deviation, just square root that 2,075, which I did. I got about 45.55. Hopefully you guys got something similar when you did this, especially if you're doing it along with me. Now I have my mean and my standard deviation. They want me to find the probability that the 7 men and 5 women will overload this elevator. Now, it has a carrying capacity of 2,000, so anything beyond 2,000, it's going to hurt the elevator. It's going to break it a bit. So what did I do? Those of you who've had me in the past, or maybe have me now, know I love drawing my normal distributions. I did just that. I did not include things like the z-score. I probably should have, but for the sake of doing this at a relatively quick rate, I just include the pounds down here. So I started with my mean, went up for my standard deviations, went down. And you notice I did establish my empirical rule here. 68%, 95. I only went 2 standard deviations out. And I represented what percent of data between each specific standard deviation. Then you'll notice what I did was I shaded in specifically from 2,000 pounds on. You'll notice I did that. It went from 2,000 pounds all the way up. This is what I need to find out. I was able to ballpark that, hey, 13.5 plus 2.5 is about 16. Plus I'm getting a little bit here. I could probably figure this is probably going to be about 23 pounds. So what did I do? I use norm CDF, because anytime I have a normal distribution, I'm trying to find the percentage of data between 2 points. That's what I use. So that's what I did. And why did I use a normal distribution here? Because I know both distributions are normal. When I combine 2 normal distributions, guess what? It becomes a normal distribution. So my lower was 2,000, and then my upper was upper infinity, because frankly, anything above 2,000 is going to break that elevator. Had a mean of 1,970, standard deviation of 45.5. Use norm CDF on my calculator, and you notice I labeled everything. Always want to do that, especially when it comes to that AP exam, if you're taking that in May, because they want to see these labeled. You want to make sure you just aren't using calculator functions. Plug them in, and if you notice, my answer was really close to my estimate. It was really close. I guessed about 23%, and it ended up being 25%. So that's why we always go with this. Always shade it in, and then you can ballpark what you're going to get. So hopefully this ultimately helps you when you're getting that free response question, when you get something like this, you have to combine random variables. Best of luck with future questions. If you have any questions,